This is a recap for AQA Psychology research methods that can be assessed in all 3 papers, and particularly will have 48 marks in paper 2. So these are the, in order, things that I think should be reviewed. For example, writing a hypothesis, you need to remember that these are the steps to take. First, you have to establish, is there a difference or a relationship that you're looking for? Basically, if you have an independent variable, then you know that you're looking for a difference. If you have 2 what we call covariables, then you're looking for a relationship. Remember, the hypothesis is a prediction, so you're either predicting a difference or a relationship. Once you've done that, you identify how the variables have been operationalized. That means how have they been measured. So you can't talk about like memory, but you would talk about scores on the memory test, for example. And if you are testing for a difference, remember that you have to show comparison between the different conditions. So saying those with similar words scored better in the memory test would be incomplete. You have to say compared to those with dissimilar words, for example. And lastly, you have to look at whether the hypothesis is going to be directional or non-directional, meaning are you predicting for a difference a higher score for one condition rather than another, and for a relationship a positive or negative correlation. You can pause the video and look at some examples below. Also, a reminder that directional hypothesis is also known as one-tailed because it's one single direction, and non-directional hypothesis is also known as two-tailed. Sometimes the tables of critical values for the inferential tests refer to one-tailed and two-tailed rather than directional or non-directional, so be sure that you know both these terms. In the syllabus, it specifies that for sampling, you need to be aware of the difference between population and sample. It's quite simple. The population is the entire group, and the sample is the people you actually use in your study. They might ask you an applied question to identify the population referring to your target population in relation to the sample that you're using. So you just kind of think, who do I want to generalize the findings to? In sampling, the most common mistake is confusing systematic and stratified sampling. So remember, systematic uses a system, every nth person. It's a type of random sampling, but it uses a system to select people from a list. You need to have a list available in order to carry out systematic sampling. Whereas stratified is to make the strata, the groups, the layers in the population represented. In a random sample, by chance, you might happen to have a sample of all men or all white people, for example, whereas a stratified sample identifies the kind of subgroups of people that you want in your sample and then selects them in the proportion they appear in the target population. So if you've got an office that has 75% of men and 25% of women, then you will have 3/4 of your sample made out of men and 1/4 made out of women to represent the strata in the office. When you're evaluating on samples, again, the syllabus says implications of sampling techniques including bias and generalization. So bias can happen from the experimenter's point of view. For example, deciding the groups. Why are you choosing to stratify by gender and not by ethnicity or age, for example? And it can also happen on behalf of the participants, for example, volunteer samples being extra keen on pleasing and therefore being more vulnerable to demand characteristics. Generalization is simple as the extent to which your sample is representative. What I say here is to nuance it. It's not always a yes or no answer. For example, random sampling, theoretically, everyone has an equal chance of being selected, so it should be representative, but by chance, some groups might be excluded. In systematic sampling, although there seems to be an objective system to select, if you've got periodicities, that means a certain pattern in your list, that might be reflected then in some people just not being selected. Just a reminder, the purpose of the pilot study is to check equipment, timings, the practicalities of running the study. It's not to check whether your sample is representative, whether your hypothesis is right. It's just to see whether your study is viable practically, whether the questions are relevant. If you're in your pilot, people don't understand the questions. It's a run through of your experiment. It's not to see whether your results will be the ones you hope for. Just a reminder, the difference between confounding and extraneous variables. Confoundings actually impact on the independent variable, and therefore on the dependent variable there's nothing you can do about it. They confuse your results. The easiest example is gender and sex. If you're looking at gender differences, you can't exclude hormonal differences between men and women, so that confounds. You can never really conclude whether the independent variable was gender in terms of the social expectations of gender, or whether it was down to hormonal levels. So confoundings are described as varying systematically with the independent variable. Extraneous, on the other hand, is a really wide range of factors that might be impacting on your dependent variable, meaning that you can't be sure that it was the independent variable that caused it, but that you can intervene and control for. So demand characteristics, this is the description. Demand characteristics is not the reaction. Demand characteristics means the things in the experiment that might give away the aim. Okay? And therefore, a consequence of these demand characteristics is that participants might act in a certain way. So remember, the definition of demand characteristics is this one at the top, and then a consequence of this demand characteristics is the reaction of participants to them. So a difference between investigator effects and investigator bias, so you don't get confused. Investigator effects is something that usually is unintentional. It might be the behavior, tone of voice, body language, facial expressions, even the looks of the experimenter that cause an impact. So both of these are extraneous variables, but for different reasons. Yeah. Whereas an investigator bias is to do with the investigator's expectations. It might still be unconscious, however, it might be in terms of designing the study in a certain way, for example, including some leading questions, collecting the data and analyzing it in a way that kind of points towards their desired outcomes. So whereas investigator effects will only happen during the data collection because of the way the investigator behaves, the investigator bias can happen throughout the research process up until the interpretation of data and conclusions. Experimental design, remember, repeated measures are the same participants in all conditions. Independent measures are different participants. A matched pairs design is still different participants, but because you pair them based on certain criteria, you're trying to reduce individual differences. That's why in the context of inferential testing, we consider a matched pairs design related, like the repeated measures design. These are just some points. Use of counterbalancing will only happen in repeated measures design because the other two designs have different groups of participants, so they only take part in one condition, so there's no order effects. In terms of convenience, the repeated measure offers us the opportunity to test the participants twice, and that means that we produce with the same amount of participants double the amount of the data. So the difference between random allocation and counterbalancing. Random allocation can happen in independent measures and matched pairs design, whereas counterbalancing only in repeated measures. What happens is because your participants will only be in one condition, you randomize how they end up in one condition to control for, well, not control for completely, but reduce participant variables. You can't control completely because, again, because of randomization, some people of a certain kind might, by chance, all end up in group A and the others in group B. However, the way you increase control in independent measures and matched pairs would be through random allocation to the conditions. So the term randomization is a broader umbrella to talk about how we can equally have the same chance of either presenting things in a different order or allocating participants to different conditions. So randomization can be used in all three types of design, and you can use them through allocation to conditions in independent measures and matched pairs, and the order of the conditions for repeated measures. Another area in the syllabus that is mentioned is how to control for these extraneous variables. So one of the simplest ways is standardization. So this is just a reminder that that means having the same setup for every participant. So everything except for the interdependent variable, that is what you actually want to vary, has to be the same. So if you're looking at stimulus material, amount of time presented, the type of questions, the instructions, everything has to be the same for every participant in order to be certain that the dependent variable is caused by the changes in the independent variable. So if they were to ask you why standardization is important, it's because it allows us, A, to make the study replicable and therefore to retest the hypothesis, but also to ensure that the differences in results are due to the independent variable and nothing else. So another tricky one is the decision of what type of experiment is being used. Usually the confusion is between quasi and natural, or natural and field. So make sure when you're answering research methods questions that you're taking your time and that you think step by step about what you're doing in the context of the question. So first of all, you have to ask yourself, would the researcher be able to allocate participants to the different conditions of the independent variable? So for example, if I'm looking at the difference between male and female, I can't decide whether my participant goes in the male or female group. It's a pre-existing characteristic of the participant. So the answer is no. Once we've said that, we look at whether the independent variable is something to do with the participant, so gender, age, ethnicity, or if it's something naturally occurring. So natural experiment means, is the IV naturally occurring, not the setting? Be careful. So a naturally occurring event might be whether I was in a certain place when there was a hurricane and how that affected me. So if being in closer to the hurricane compared to further away affected my well-being levels. So that would be a natural experiment, because again, the researcher can't decide who was closer and who was further away, but they can measure the outcome. And that's why neither of these are pure experiments, because the IV cannot be manipulated. You can only measure the outcome of that independent variable. On the other hand, if you can manipulate the independent variable, then the difference between field experiment and lab experiment is to do with the setting. Now, it's not in a field or outdoors that we see a field experiment happen. It's anywhere where the participants would be anyway. So if I carry out a study in a classroom where students would have a lesson anyway, that's a field experiment. But if I ask a group of teachers to come to a certain classroom to do a memory test, then it's a lab experiment, because they wouldn't have been there anyway. Sometimes they're going to ask questions about a certain setup experiment, expecting you to understand that certain conditions are not possible with certain types of experiment. For example, in a quasi-experiment, because the IV is pre-existing, you can't randomly assign participants and you can't use a repeated measures design. You also are most likely to have to use a volunteer sample, because if you take a random sample, you might end up with, for example, people of only one gender or no one with a mental health diagnosis. So that's one thing to look out for. In a natural experiment, again, because you're not manipulating the IV, you can't use random sampling. You'll usually, nearly always, have to use opportunity sample, because the participants are selected based on pre-existing groups and events. Again, repeated measures can't be used, because if we use the example of the hurricane from before, you can either be close or further away. You can't be both. So they will expect you to know that if it's a natural experiment, you need to know what kind of design is being used without having had any information explicitly about the design. Lastly, Field experiments, because they're happening where someone would be anyway, will also typically use an opportunity sample, although sometimes if prior access to participant lists is available, there might be a way to manipulate and stratify the sample, or to make sure that certain people are in a certain place at a certain time, but within still the environment they would be. For example, if I pretend there was a room change in a school, to make sure that I have certain students in a certain group, and that would include some deception. So just a quick reminder, in structural observations, time sampling means recording at fixed time intervals regardless of what is happening. Yeah, so 30 seconds for every 5 minutes, you watch for 30 seconds, you write down, and then you do it again 5 minutes later, etc., etc. It's good for measuring the frequency or consistency of general behaviors over time, whereas event sampling is specifically targeting behaviors that you've already decided you want to see, and it's used when the behavior that you're looking for might be infrequent or unpredictable, so you want to catch it every time it happens. So this is just a question that has been asked to me by my students. What lie scales? They appear in the mark scheme sometimes in options on how to improve validity of questionnaires. So this is just a summary of what we mean by lie scales. They're deliberately placed questions that are trying to see whether a person is trying to make themselves look better than they are. Okay, so they're statements that most people would agree with occasionally if they were being honest. For example, I've never told a lie in my life. I never feel angry at other people. These are things that if someone is being honest would not completely agree with these statements. If they do, if they strongly agree with all these statements, that might invalidate their results. They're usually used in personality tests, self-report surveys, or sensitive topics, just to make sure that, to kind of reduce the impact of social desirability bias. Remember that controlling for extraneous variable will always increase the internal validity of your research. This is another reminder, ethical issues are not the same as ethical guidelines. The guidelines are obviously the things that we expect psychologists to do to make sure they protect participants, whereas the ethical issues are when they don't follow the guidelines. So make sure that you don't get these confused. Don't just look at one word, ethics, and go into answering your question. Look at what are they asking you. Are they asking you issues, guidelines, dealing? And on the top of that, in terms of types of consent, just a reminder, you can have simple informed consent, where you ask participants whether they're happy to take part and you give them all the information about the setup. You can also have presumptive consent. If you don't want to ask the participants to not bias their response, you might ask a similar group of people, if they were to have a certain amount of deception carried out on them for the purposes of your experiment, whether they would be retrospectively okay with it. And that links into retrospective consent. That means asking participants after you've carried out the research whether they're happy for you to use the data, whether they want to withdraw it retrospectively, and maybe explain that you had obtained presumptive consent, so you thought it would be all right. This is when deception is necessary to not bias results. Prior general consent is when you ask participants to agree to take part in studies where they might not be told everything initially. For example, in Zimbardo's study, they knew they were going to be prisoners, they knew about the prison, but they might not have known that they were going to be picked up by a police car, for example. So that would be general consent, prior general consent. This is just an example of a checklist of what you want to include if you're writing a consent form. Obviously, the general purpose of the research, all the details that participants would not want to know. You have to think, if I were to take part in a study, what would I want to know? I want to know how long it is, what tasks I have to do, if there's going to be anything embarrassing, what to expect. You have to include ethical guidelines, no pressure to consent, that they can withdraw at any time, that the data will be confidential, ask questions at any time, And then it's really important, and that last point, if you don't include the right format, you might not get any marks at all. Okay, you need to include space for the participants' agreement, so a signature. It has to be written to the participants. So, dear participant, thank you for considering our study. Give all the information, and then you need to give space for the participant to sign, date, and print their name. Just a reminder of the purpose of the peer review. Quality control, yes, most people remember that, but also originality. If a paper is sound, valid, and controlled, but it's just repeating things that we already know, then the chances are it still won't be published. Remember that the main purpose of the peer review is to quality check before publication. So if something is quite boring and uninteresting and doesn't stimulate further scientific inquiry, it might still not pass the peer review. There's another detail here, improvement suggestions. The peer review is not a yes or no answer. Sometimes the paper will be returned for edits, minor or major edits, so still be considered if the format or the language sometimes or the length of it is edited. Another reminder, these are the areas you could comment on should they ask you about implications of psychological research for the economy. This is something that usually pops up in other topics, not in a kind of plain research method question. In paper 1, maybe paper 2, maybe the other topics such as approaches or biopsychology in paper 2. So it's to do with productivity. So obviously, if we know about mental illness and stress and how to reduce it, we can improve productivity and reduce absenteeism from work. Consumer behavior, conformity can make us understand why people might buy one product rather than another. The cost of mental health, preventing mental illness obviously reduces the cost and the burden on the NHS. Education and training, research into memory, for example, can help students perform better and therefore at a wider scale economic growth for the country. And policy development, obviously public health campaigns are based on psychological knowledge, and that can also reduce the costs of healthcare. Just a reminder, you want to memorize this definition. Validity is where I'm measuring what I aim to measure. Then there are two subtypes. Internal is to do with control of extraneous variables, whereas external is to do with generalization. Internal, you've got phase and concurrent validity that you need to know about, and for external, you've got ecological and temporal. For reliability, you just need to remember that it means consistency. You need to know about inter-observer and test-retest reliability. Features of science, here's your mnemonic, theory construction. Can I build a universal law based on the findings? Hypothesis testing is how can I verify that these findings reoccur consistently before I construct a theory? Empirical method, can I use data that can be experienced through the senses, usually sight, observable data rather than abstract concepts? Paradigm shift, does the research in question build up enough evidence to change the set of beliefs that exists about a certain concept in the discipline? Replicability, can I repeat these studies consistently? And objectivity, is there a lack of bias? Finally, falsifiability, can I prove a hypothesis wrong? If it's unfalsifiable, like for example Freud's psychodynamic approach, where any outcome could mean anything because it's all happening in the unconscious and all based on interpretation, then it becomes unfalsifiable and therefore unscientific. Usually when they ask you why one of these features is important, they expect you to tie these features together. So for example, in order to construct a theory, you need to test the hypothesis and falsify the null hypothesis consistently. The only way to do this is for the hypothesis to be replicable, because then you can test and retest the hypothesis until you can be certain that the null hypothesis has been falsified. operationalizing variables into empirical measurements allows for this objectivity to be achieved. If a new theory is confirmed, a paradigm shift will occur. Now, this is tying them all together. You're not expected to bring all 7 in any answer, but it's just to show you how they're all connected. Another reminder, thematic analysis versus content analysis. They have the same first step, reviewing the data, but in thematic analysis, you're going to identify themes, and the most important thing is that once you've got examples of themes, you're talking about organizing information into themes. Whereas in content analysis, you're identifying categories, coding categories, and then you're going to count them. Now, if you talk about counting in thematic analysis, that immediately voids your answer. One thing that they both have is, like everything in research methods, you'll be asked to run it on a certain theme or a certain topic, and you need to bring specific examples for both of either themes or categories in order to be certain to hit the whole marks, because it will ask you in this study. So don't forget, in this study means always refer to the details of those studies. Reporting psychological investigations is on the syllabus, so you're expected to know all the sections that are included: abstract, introduction, method, results, discussion, and referencing. Just a mnemonic for referencing: spend your time learning psychology. For referencing, you're expected to present it in this order format. So the surname has to go first, and the year, title, location, and publisher. If you don't put the surname first, you automatically get 0 marks. It's only a 2-mark question. It has been in the past, but it's worth knowing the order. Remember, the difference between primary and secondary data is not who collects it, but why it's collected. If it's being collected for the purpose of the investigation, it's primary. If it already existed and you're just using something that was collected for a different purpose to answer your research question, then it's secondary data. Now, distributions, the thing to remember, well, that's how I remember, negative skew is when this looks a bit like a minus. So it's negative. Now, once you remember that, you always remember that the peak is always going to be the mode. If the mode is higher, then that means that this data has very high results. So if it was a test, it would mean that it's a very easy test. Now, once you remember this, the positive skew is just the opposite. Positive, there's no minus here, it's at the end. So that's a plus, and that means that the test was very difficult because the majority, mode means the majority of people scored quite low. Okay, obviously this is going progressively higher, so the majority scored low. So if they were to say that an experimenter found a positive skew in their test to assess memory, how could they modify it? They might make it a bit easier, maybe have less questions or give participants more time in order to have a normal distribution, and therefore make sure that the test makes a distinction between high and low memory, whereas rather than having everybody score low. The kind of question you can get on this is a table like this, giving you mean, median, and mode. And you can see here, you've got mean, median, and mode, and you can see that the mode is higher. That means that we've got that profile where it peaks higher up. Okay, so we've remembered here that this is a minus, and therefore that would be a negative skew for group A. Whereas in the other one, we've got the opposite. So when we look at the results, we've got a negative skew for A, and we've got a positive skew for B. Just another reminder is, if you have scores like this, very, very similar, even if this is slightly lower, we would consider this a normal distribution. You can try and answer the next one. Pause a second, and then I'll put the mark scheme out. So as we said, for group A, you would say that it's symmetrical, so it's a normal distribution, whereas for group B, you would say it's positively skewed. So always remember, if you see a table that gives you mean, median, and mode, it's asking you to comment on normal versus skewed distribution. Do not confuse distribution with dispersion. Dispersion is this indication, the standard deviation, how spread out my data is. So it would be how wide or narrow my distribution might be. Whereas mean, median, and mode tell us whether it's normal or whether it's skewed. Types of data, remember, nominal data is frequencies. So what's your favorite color? What's your favorite subject? How many people said maths, English, science? So what you're measuring, remember, nominal data will be presented in numbers. But what you're looking at is, what do those numbers represent? If they represent a frequency of categories that you can't put any specific order, like green, yellow, and blue, you can't put them in a special order numerically, and therefore that means the frequency of data. That also includes, for example, yes/no questions. Ordinal data are the most common in psychology because anything that is scores or levels, unless it's specified that they have been standardized, that would be ordinal data. You can put them in order from largest to smallest, but there's a subjective element to them. For example, if I'm asking to score the level of attractiveness of people in pictures, then me giving an 8 wouldn't correspond to someone else giving an 8. Maybe some people never give anyone a 10, and some people do. So obviously a 10 for one person will correspond to an 8 to another person, meaning that there's not an objective measurement there. Same for things such as self-reporting on stress levels, happiness levels. There's too much subjectivity for it to be considered interval data. Interval data is the most precise type of data, so measurements such as height, weight, minutes, things like that, that are objectively quantifiable. And also if a test is standardized. So for example, IQ tests are considered interval data because they can be standardized. Now, they have asked in the past to convert levels of measurement. So what you want to do is be aware of the fact that you can convert ordinal data into nominal data and vice versa. So you can usually go from the highest form of data to a lowest form of data, but not vice versa. So if you have interval data, for example, you could take mood scores from highest to lowest. In this case, it was a mood score that was standardized. And what they're saying here is that to convert interval data into ordinal data, you order it, so you rank the data, and then you give a rank place to every scores, and the equal scores would share a rank space, a place. And nominal data, you would just get the scores into categories, and you could say either under 40, between 40 and 60, or simply high, medium, and low. So you see, you're making it into categories rather than numbers. So you can convert interval into ordinal, ordinal into nominal, but you can't convert nominal into interval. You'd have to use a new measurement. This is important. If they ask you to convert, they're not asking you to assess in a different way. They're asking you to take the existing data and make it into a different level of measurement. Lots of people lost marks because they suggested a new way of assessing mood rather than converting the existing data. Now, for choice of tests, you just need to memorize this table. You need to memorize it in order. And the only one that you'll be asked to calculate is the sign test. All the others, you just need to know what they are. And as I said, remember that repeated measures and matched pairs are considered related for the sake of testing statistically. Some keywords that they might ask you to define: significance, whether the difference is large enough to be meaningful, and probability is the likelihood or the probability of results being down to chance. Type 1 error is an error of optimism. The way I remember this is that first of all, we must be optimistic, then we can be pessimistic. And that's the way you can remember type 1 error. Remember, the risk of making a type 1 error is always as high as you set the p-value. So if the p is set at 0.05, then the chance of making a type 1 error is 5%. If you set it at 0.1, then it doubles the risk of making a type 1 error. With type 2 error, it's exactly the opposite. It's an error of pessimism or false negative, and it will happen when your p-value is too tight, like 0.01. You're not leaving any room for chance, and therefore you might reject a hypothesis that in fact is significant. Now, the reason we set, and this is a standard answer that you want to memorize, if they ask you why is the p-value 5%, you're saying it's a compromise, reducing the risk of both type 1 errors that would happen if the p-value is too lenient, so 0.1, 0.2, and type 2 errors that happen if the p-value is too stringent. Don't forget the risk of making a type 1 error is always as high as the p-value is set. So the more lenient the p-value, so if it's 0.1, 0.2, then it's 10, 20% risk of making a type 1 error. But if you go too far the other way, you might make a type 2 error. 5% is considered the compromise between those two. So here's a tip for when looking at critical values. Let's say, for example, here we've got our level of significance. Let's say that our calculated value is 0.42, yeah? And also, because this is a correlational coefficient, remember that if it was negative, let's say that it's negative 0.42, and I'm using a directional hypothesis, so one-tailed. Remember, directional is one-tailed. I can look at my p-values for 0.05, and if the calculated value has to be higher than the critical value, 0.42, you have to ignore the minus, because if not, it will always be lower than anything. So we just ignore the sign, and we look at 0.42, and it is larger than 0.36 at the p-value of 0.05. Now here it's saying, also look at a lower p-value. So is it still significant at 0.025? We see that that's a bit higher, but 0.42 is still higher. So that means that you can be more confident because there's only a 2.5% risk of making a type 1 error. As I mentioned, the sign test is the only one that you have to calculate, so just remember these steps. First of all, you put a plus if the second value is higher, a minus if it's lower, and remember to put a 0 if there's no difference between the first score and the second score. Count the number of pluses and minuses, and this is what you want to remember. The least frequent sign is your S, and this is your calculated value. Once you've done that, the last thing to remember is that N is the number of participants minus the ones that had a 0. So those are the only things to remember. Once you've done that, it's exactly like the same as any other statistical test. Other reminders: descriptive statistics means how you describe your data. So it can be measures of central tendency, that means mean, median, and mode. Measures of dispersion, so standard deviation and range, and graphs. Levels of measurement: when they ask you what level of measurement, or you're choosing what test, inferential test, level of measurement refers to the dependent variable, not the independent variable, unless it's a correlation. If it's a correlation, you've got two covariables and you choose the weakest level of measurement. So if one is interval and one is ordinal, then you would choose the test for ordinal data. And last thing, if they ask you why you would use a histogram, remember that you refer to continuous data.